Alrighty, let's undo some derivatives. Okay, so f prime equals 2. This is our derivative. So we want to do the antiderivative. And we're always going to do it with respect to the variable present. So that's the dx. And our rule for the antiderivative of a constant is like that. That's a k on the end there. So the antiderivative is that you're going backwards to the derivative. So if I were to take the derivative of my final answer, so if we say that that is f, and if I do the derivative, well, what's the derivative of 2x? 2. What's the derivative of a constant? 0. So that's the idea, is that when we're finding the antiderivative, we're going backwards to the original function. So let's try the next one. You got to do that notation there, or your teacher will be very upset. So what's the derivative of e to just the variable, e to the x, for instance? The derivative is e to the x. So the antiderivative, the same thing, nothing changes. Now we've got a 2 times p. So just like before, coefficients are always there. And think about the derivative. We subtracted 1 from the exponent, but the antiderivative, we're going to add 1. And then divide by that new thing. And then, of course, do a little simplification. So think about the derivative of that answer. What's the derivative of e to the p? E to the p. What's the derivative of p squared? 2p. What's the derivative of minus p? Minus 1. And the derivative of our constant at the end, 0. So anytime you do an antiderivative, you should be able to find the derivative of your answer, and it be that function you started with. Let's do number C here. Just like when you did derivatives, you don't have a rule right now for denominators or multiply, so you need to convert it to that power rule so you can find its correct derivative. Antiderivative. I'll get it right here in a second. So coefficient is always there. Add 1 to the exponent, divide by that new number. Simplify a little bit if you can. And there is that answer. So let's try a couple more. So our antiderivative, and just like our derivatives, we did this a second ago, but every time you have a plus or minus, you're separating terms and you do them one at a time. So the antiderivative of negative 6c, negative 6 coefficient stays there. Apply the power rule, add 1 to the exponent, divide by that number, and then minus 2, and that gets our z. And you always have that plus constant coefficient at the end there. And take a pause and find the derivative of your answer And it should be the function you started with. If you made a little mistake, that extra step of finding the derivative might help you out. Our next exercise. So this one has a special rule in it. Remember when we did the derivative of a natural log, its answer was 1 over x. So when we see that 1 over x, we are going to have to do the antiderivative to go back to the natural log. So that's in this one. If the exponent is anything other than -1, then it's exactly what we've done a couple of times already. Add 1 to the exponent, divide by that number. Add 1 to the exponent, divide by that number. But if that exponent is -1, then our antiderivative is going to have the natural log. And because we're going backwards, we have to account for the possibility the number might have been positive or negative. So we have to have absolute value bars there because the natural log is not defined for negative numbers. So now, a little bit of simplification. And if you try the derivative of this final thing, again, you should be able to go backwards to your original function that you just did the antiderivative of. And last exercise here. So we've got some radicals. So all those exponent laws that you learned for derivatives, you need to use here. And I'm going to write this one differently just to emphasize we're doing these separately. So you can write it separately like this or just the same way that we did before. Another thing to emphasize is that coefficient is always there. So you can move it in front if you want to, and if that helps. So this is just a variation on what I just did before. So coefficient's always there. Add 1 to the exponent. Divide by that number. Coefficient's always there. Add 1 to the exponent. Divide by that number. Plus k on the end. That. And then clean it up just a little bit. Remember, that simplification is mostly just for typing in Excel. And that is the end of this worksheet.